13-3. Physics and the quantum mechanic model. Light and the atomic spectra. Light and the atomic spectra. The quantum mechanic model of the atom grew out of the study of light. According to the wave model, light consists of electromagnetic waves. Electromagnetic radiation includes radio waves, microwaves, infrared light, that's visible light, ultraviolet waves, and X-rays and gamma rays. Parts of the wave. Well, we have a wavelength that's from crest to crest or from any same point on a wave. We have an amplitude, that's the height above the rest line. We have the origin or the rest line. We have a crest, we have a trough. Crest is the high point, trough is the low point. Parts of the wave you can find on page 372 in your textbook. Origin is the baseline of energy. Crest is the high point on a wave. Trough is the low point on a wave. Amplitude, distance from origin to the crest. Wavelength is the distance from crest to crest. Wavelength is abbreviated by the Greek letter lambda. It's upside down Y. Light in the atomic spectra. Waves travel at 3.0 times 10 to the 8th meters per second in a wave, or in a vacuum. That's in space. Amplitude is the wavelength's height. Wavelength is the distance from crest to crest. Light in the atomic spectra. Frequency is the number of wave cycles to pass a given point per unit of time. Frequency and wavelength are inversely related. As wavelength goes up, frequency goes down. Speed of light, symbolized by the lowercase c, equals wavelength times frequency. Unit of frequency is the hertz, which is cycles per second. A prism separates sunlight into a spectrum of colors. Red has the longest wavelength and the lowest frequency. Violet has the shortest wavelength but the highest frequency. When a gaseous or vaporized element is excited by electricity, only a few lines are emitted. White light should be a continuous spectrum of emitted or all colors. Here's a electron spectrum of neon, and it has very signature looking lines. Here's the picture for mercury, and here is the signature for mercury with the spectral lines. Every element will emit light when it is excited by the passage of an electric discharge through its gas or vapor. And here is the signature for sodium. Atomic emission spectrum is produced by passing the light emitted by an element through a prism. The few lines of light produced is called the light spectrum. The emission spectrum is unique to that element, and it helps to identify an element. Again, here's mercury and here's neon. Thank you.